All right, what is up, guys? Today I'm going to talk about question 1834, single-threaded CPU. Uh, the question is, the CPU is only single-threaded, and we have tasks scheduled at each time. For example, at 1, 2, 3, 4, and each task takes a third amount of time. And if a task that is scheduled after another task, but the previous task hasn't finished, it has to go to the available task queue and waiting to be executed next. And the rules here is um, we for the how do we determine which task to process? Is we want to process the task with the shortest processing time that is in the queue. And if if two tasks have the same processing time, we need to process the one with the smaller index. And the idea here is um, we will maintain a priority queue and with a comparator specified using the rules here, as specified here. And then therefore, each time we pull from the priority queue, the first element is always what we're going to process next. And if the priority queue is empty, we know that we can process whatever is in the task array safely. And yeah, that will be the algorithm. And then there's some pre-processing that's required. For example, there's nothing, it didn't say anything about the provided task being in uh, ascending order, sorted by time. So we need to sort that first. And because we also need to, because we're returning the index of each task, we also need to keep track of that. So to do that, I'm going to create a separate task class to store all information like this. So we'll have a helper class called task. What the task is going to have is index, in queue time, and also processing time. And also a default constructor. Right. Processing time is equal to processing time. All right, and now we need to build a array that stores all the sorted tasks. So let's first get the length, and then we need a separate task array. This array is equal to, and then we need to put every task in there. So iterate through every task inside tasks, and then array. Actually, we can do this as we index. And then it's equal to new task with a index of I, and in queue time will be tasks I0, and duration will be tasks I1. And then we need to sort it in ascending order, time ascending order. So array sort, we need to sort the array, and we need to give it a comparator. And here, okay, so I'm gonna return integer to compare a dot in queue time and b dot in queue time. It is good to use integer compare because there might be, if we're just doing minus, there might be an issue of index out of bound or overflow of integers. So integer compare provides a safe comparator, so we can just use that. Then I'm going to declare a priority queue, QUEUE, that takes tasks as its object. And we also need to pass a priority queue. And passing a comparator using the rules here. So for the comparator will be A, B, and the rules will be if A dot processing time is equal to B dot processing time. That means we need to do the comparison on its index. So return integer dot compare A dot index and B. Otherwise, just return the comparison on its processing time. So A dot processing time, B dot processing time. Now we can populate the output index array. So let's call it answer is new int array. And we will also need two pointers that points at the current task that we're processing in the array, and also the current empty spot of where we can insert new. We can process a new task for the answer. So we can have a answer index is equal to 0 and also a task index. And we also need to keep track of the current time, starting at time 0. And then we can start iteration. So while we haven't populated everything, we need to populate the priority queue. So if the task index is less than n, and the task that we're trying to process, which is array task index, the start time, in queue time is less or equal to current time. That means that's something we need to store into the available task queue, which is our priority queue. So we need to offer this current task, which is array task index, and increment the index by 1. After exiting this while loop, we know where we need to look at whether we need to update the current time and find a appropriate task as our result. So if our priority queue is empty, so there's two cases. So if our priority queue is empty, that means there's our CPU will idle for a period of time. So that period of time will be so we need to update our current time to be its in queue time. the queue is not empty, we know current time will be updated to the first element plus its duration. So, which is its processing time. And then we can for sure putting a element which is um, equal to priority q dot, which is its first element. So it's full, and we want to get this index to that. And then we can just return our answer array. Let's see. Line 15, we want to have index. All right, cool. I think this will do. There we go. So the time complexity, we're doing a sorting algorithm, which is the sort time will be all of n log. And actually, the sorting is happening here. And then we're iterating through the entire array once. And also, we're doing priority queue edits, which is for each edit, it's log n, and for n edit, it's also n log n. So overall time complexity, I would say it's still n log n for space complexity. We're using some extra space called array. So that's just on extra space. And we're also keeping track of a priority queue, and that is at most length of task as well. So that's also so the overall time complexity is n log n, and space complexity is O of n. Yeah. So just to repeat, while we haven't found every solution, we continue to find any possible tasks that can be put into the priority queue. And how do we do that? We compare the current task's time and the CPU cycle time, basically. And if this task is less than the current cycle time, that means that's something we can process, but we don't have time to process. So we need to add that to the priority queue. And then if the priority queue is empty, you can just update the current time to the next. If the priority queue is empty, that means we enter a idle, CPU is idling, and we can advance our current time pointer to whatever the next element in queue time is. And if the priority is not empty, that means there are tasks in the queue that we need to process right away. So we can just update the current time and find a task that we need to process and process it right away and add it into our solution. Yeah. All right.